Welcome back, boys and girls. Today I'm going to be covering the service discovery package that was added as part of .NET Aspire. I don't know if the .NET Aspire hype train is still going. However, I was curious about creating a peer-to-peer communication between my server nodes. So in this video, I'm going to be demonstrating that. So if you're interested, keep on watching. Also, I wanted to know, anybody else using .NET Aspire? Is it useful? I know it's still kind of like in preview, but no. Is anybody actually using it? Please let me know in the comments. With that, don't forget, if you're enjoying the video, leave a like and subscribe. If you have any questions, make sure to leave them in the comment section. And don't forget to check out the description. And let's go ahead and get started. Here I have a very simple, well, just basically an empty web template. So let's go ahead, pull up Nugget packages and search for service discovery. So the actual thing I had to search for is Microsoft extensions .service discovery. So these builds are with .NET 9. I'm going to be using .NET 8. So let's go ahead and add this package. So what this package does is it gives us something along the lines of this. In services, we're going to add service discovery. We're then gonna go into, well, we'll need a couple of things, but let's actually just go through this like this. We'll add an HTTP client. I will just call it the, I don't know, let's call it test. Here we'll have HTTP client configuration. And hopefully as part of, hopefully you're familiar with Aspire and that when you're trying to make HTTP calls or you're configuring your addresses for services, you're not putting IP addresses, you're doing something along the lines of this, where you're just saying, look, connect to this test domain, right? So maybe, let's say, I'll put RC test for raw coding test, okay? Let me go ahead and copy this, place this over here. The tooltip is like taking up half my screen. But anyway, I have added this HTTP client. I have added service discovery. So what you actually need to do in addition to this is say that this particular HTTP client needs to be connected with service discovery over here. Okay. So with that done, let me actually, and that will have to do. So when I go onto the root here, I go to HTTP client factory. So HTTP client factory, I'm going to give this a body and let's go ahead and create our client. This is going to be RC test. So this will force this HTTP client to be created. Let's have HTTP over here. HTTP, we will then get a sync on just /. This is going to give us a response, and then we're not going to do anything crazy with it. This is a task, so we'll have to wait on it and make this asynchronous content, read as string async. So we're not doing anything crazy. We're just going to call this URL and we're just going to make sure that it goes ahead and passes this call along to some kind of other service. So I'm going to go ahead and create two new web projects. First one will just be Polo. I'm going to be calling out to these different services. Basically, in the end, what I want to do is these applications spin up like 3 of them and for them to talk to each other. If you're wondering why I wanted to do this, effectively, I wanted to have this peer-to-peer communication to balance workloads. So if one was doing a little bit too much, I wanted to say, actually, you other node take some of this work. Okay, so you can do this communication via queues and stuff like that. But I'm exploring. I was learning. So that's the reason I was interested in this whole topic. So anyway, here we have Polo. I'm going to go ahead and add another project, which is going to be Marco Polo. Let's say Marco, right? Going to have a little Marco Polo going on here. So Polo, instead of hello world, will return Polo. And we're going to just go ahead and run him. That thing tried to update, but okay, new terminal. Very good. So this is going to be working on HTTP. I would ideally like it to launch on HTTPS, but no bother. So on a HTTP RC test, That's where I want to go. So then I want to launch Marco. Let's go to Program CS, change this to Marco, and launch this as well. Still trying to update this game. Not today. Recording a video today. Okay, maybe you get to update. All right, there we go. Persistent little MF, right? So 5032 and 5056 are our addresses where we effectively want to forward these calls. Now we'll have to add configuration into here, which will have to go something like this: service, or maybe services. What kind of services do we have? I have gone ahead and registered the RC test service, right? Because this is effectively the domain, and this maps to this domain over here. On here, I believe you have to say something like HTTP, and then inside of this array, you supply addresses. So let's go ahead, take this address, place this over here, copy this once, and then the second address, 32. We'll do this, okay? So if you're using HTTPS, you have to like put HTTPS over here, but I am not doing that. With that registered, we have Polo running, we have Marco running, and let's go ahead and cd into the app. We're gonna run our application. Okay, let's go ahead and open this up, and there we go. So this is Polo, Marco, Marco Polo, right? So this is periodically calling one and then the other service. Now, if you watched my video about YARP, this looks awfully similar to YARP. Why the heck is service? Is this the same as YARP? No, it's not quite the same. If you think about YARP as a tool to forward calls to somewhere, it's a proxy configuration mechanism. So you're configuring all about how you want to take something and send it somewhere else. Okay. Service discovery is more about where you're sending it, right? So it's and that's partly what I'm going to show you how to configure in this video. Maybe these APIs will change or not, but hopefully you will get an idea that you're not trying to send something somewhere, you're trying to establish a mechanism for discovering where things are, okay? So as we see over here, we are configuring things. We're hard coding things, okay? I don't want to be hard coding. In my services, I may have 3 nodes at some point. I may have 5 nodes at peak times, 20 nodes, however many, right? And as nodes are coming up and down, I want to alleviate my, distributed locks, etc. I want to say, okay, your new node spinned up. You can have 5 of these tasks that I was taking care of, or you can pick up the new tasks, okay? Or you can say that, look, 3 of these nodes are holding 20 queues each. For the next new 20 queues, we need a new node to spin up and handle all of those tasks, okay? So depending on how your balancing strategies are, etc., what kind of problems you're solving. So anyway, the point is I will have a dynamic table for these HTTP resources. So that's what we're going to try to configure, is where are these addresses going to be coming from, all right? So the main abstraction mechanism in here is public class. Let's say I can't remember the exact class, so I just remember it was something provider factory. That's all I remember. So, and maybe it had endpoint in there. Endpoint provider factory. There we go. iService endpoint provider factory. Postgres. I'm gonna do something like this. Give this a body. This is going to have to be implemented, and what this is going to do is it has to output based on some kind of query an iService endpoint provider. Okay, so I'm just going to copy this, remove this thing over here. So Postgres service endpoint provider, and why am I naming this Postgres? I'll explain in just a second. But let's say we have the dispose function here, and we have the endpoints over here. What is Postgres, and why am I mentioning Postgres? So effectively, when you have peer-to-peer communication, you either need to have 2 peers and they have to find out about each other somehow. So you can either hard set some kind of IP address there that will always be there, Or if you want a scale-free network, you can have a hub. Okay, a hub is a place to which many nodes communicate with, and then less communications actually go between the nodes to find out about things within the network. So if a node within a network needs to find out something about the network or where things are, generally you'd go to the hub. In my case, I'm gonna have a database, PostgreSQL, act as the hub and hold any information I want, right? So database, well, it's perfect to be a hub, okay? I'm gonna cut the video here. I'm just gonna set up Martin with PostgreSQL and just make sure that it's connected. So you don't need to watch this part, okay? Here I have set up my connection to the PostgreSQL database using Martin with optimized workflow and lightweight sessions. So basically any new entities that are introduced, any new documents, they will get saved automatically. Okay, so the database is test, and I'm going to be using the terminal to connect to the test database over here. Right now you're going to see that I don't have any tables there with \d. Okay, so coming back to the code, let's go all the way back down and start introducing this heartbeat service. Right, every so often we want to be able to register with the database that we're alive, and you should be able to send us stuff. Okay, so heartbeat service heartbeat, you can call it whatever you want, but we'll call it background service. Okay, so a while loop where we have a stopping token is cancelled. I remember the English language, right? If cancellation is not requested, we keep going. We have an exception. I'm just going to console right line it, use a logger. Okay, so in the try catch here, we will want a service provider. Let's go ahead and implement this. We're going to create a scope. Right. If you watch my videos, you probably see me do this a gazillion times, right? We will get a required service, and what do we want? We want a document session, right? So document session is Martin's DB context that you don't really need to create your own version of. You don't need to create an app document session, an application document session, right? You just get an object where you can say, let's go ahead and start saving things to the database. However, I don't have an object there yet. And then you have the same save changes async. Okay, so as we're going to be doing this thing, we want to obviously have a delay, not do it every waking second. Just gonna put 5 seconds here for the delay, pass the cancellation token here, and perhaps maybe do it over here, right? So we don't cause too much, commotion with the exception throwing, right? What do we actually want to store? Let's go ahead and say node entity. So you're you're a node in the network. We are gonna have to have an ID, and this identifier can be created as the service is instantiated. So we create an ID, and this ID can be assigned over here. Node entity ID. Okay. Another thing that we're gonna need is a timestamp. So datetime offset. Let's say last updated, and we're just gonna say you could probably set this here, datetime offset etc now, right? So we set it here by default. We set the identifier over here. Let me just put this on one line because my screen real estate is already pretty bad. Because of the identifier is always going to be the same, store will figure out that it needs to keep updating the same entity. Okay, this identifier could probably live in a a Singleton service that you can retrieve this identifier in other places. However, actually that's probably going to be very very crucial. All right, so let's create a public class server ID. Okay, the server ID will just have GUID ID, and we're just gonna say GUID new GUID. Okay, so we have a server identifier over here. create a new service, add Singleton, server ID. There we go. We're gonna go ahead and inject that instead of generating a new GUID. Okay, and make this property available, get rid of this ID. And then over here, server ID, we can use that. Okay, so now our server ID is available to our whole application, and it's generated upon startup through this Singleton service. Okay, so let me go ahead and move this to their other classes so they don't get in the way. Okay, and the heartbeat, I haven't actually registered this yet, so let's go ahead and move this away as well. I'm gonna go all the way up, and instead of Singleton, we're gonna add a hosted service, heartbeat, and there we go. So let's go ahead, start this up. Let me just double check. I don't have any relations. We are gonna run this, and as the service, it should create something. There we go. If we select all from empty doc, help me select node entity table. I didn't. Okay, let me remember how to SQL, right? Select all from empty doc node entity. All right, there we go. And there is our entity, and it keeps getting updated. So if it's 1946 now, 1946, 29, 29, 29, 5 seconds passed. Okay, 34. Okay, there we go. So we have a node that keeps updating itself. Very cool. Now we actually want to be able to load up this node, or rather, sorry, not this node. We want to be able to load up this node information. What, who is in our node network? What is available? How can we distribute the load? Okay, if there are no other nodes available, we just send stuff to ourselves, right? Let's go ahead and put a breakpoint here. We're gonna put a breakpoint here. Stuff's not implemented, but let me go ahead and cancel this. Over here, I'm just gonna go ahead and return a new Postgres server provider. Okay, and did I spell this correctly? I did. Sorry. So this will need to return true. Yes, we managed to resolve the thingy. And the provider, we're gonna have to set it here. Okay, so we create our new what's it called, provider. We set it over here, and we return true that yes, we did create it successfully. Anyway, so with the two breakpoints, if we actually want to hit them, we gotta have to actually register the service. Okay, otherwise it's gonna keep using the default service resolution through the configuration. All right, this is going to be a Singleton, and the interface is gonna have to go first. So iService endpoint discovery, like that, semicolon in the end. Cool. With that, let's go ahead and start the debugger on the app. Set the debug. I'm gonna make this window just a little bit smaller. This is gonna start up, and hopefully, yep. So there we are. I'm gonna refresh this, and there we go. So the first time the application is ready and we're hitting the route, that is when it's going to effectively hit this endpoint. I don't want to open no documentation. Thank you. We're going to take a look at the variables, and specifically, we're just going to take a look at the query. And this is what's basically going to have things like, okay, what kind of request are you making and where? This is where if you need deeper configuration around, which service are we attempting to discover, and what IP address, what, URL, what domain we're calling. This is the stuff to handle that. Okay, or this is, sorry, not the stuff. This is the point at which you handle it. Okay. For all my things, currently RC test is the only thing that's kind of like the service that should be communicating with itself. I'll just say, yeah, just go ahead and resolve the Postgres service endpoint provider. And at this point, we're going to have a bunch of endpoints. So currently on the endpoints list, it's still loaded the endpoints from the configuration. So we're going to have to get rid of that. So let's go ahead and wipe it. Okay. That should no longer be there. We have change tokens, so configuration reload token, that's something else. But one thing that perhaps we want to figure out is on the iService endpoint builder, we have an iList. So an iList is mutable, so we can change the list. We cannot set a new list. So if you do have things in there, you may want to clear it, or you may want to be adding new things, okay? We have access to the features and the add a change token. This is how you're going to trigger a reload in the endpoints that are located over here, okay? So value task, so basically there is no return value here. You're kind of just populating endpoints and you're done, you're finished, okay? So currently this throws an exception. I'm just going to stop this, and instead of throwing an exception, I'm just going to say that this has completed and this has completed, okay? With that, let's go ahead and restart. While that's restarting, let's come back over here. I'm going to refresh this till we hit a breakpoint. Okay, so we're hitting the breakpoint again. First breakpoint, I'm going to play through this, and then the second one, I'll play through this, okay? And we don't have anything. So you can see here, as I keep refreshing, it's not going to create a new provider. Whatever provider it has created, it is going to keep using that. So what we actually need to do is register this, what's this, continue without changes. We're going to stop the debugger. We're going to go to endpoints and add change token. We're going to need to, well, add a change token, and this change token is going to have to effectively notify when we should update the endpoints list, okay? I'm going to say update it on the same interval as we are pinging our heartbeat to be alive. And bear? I have a little bit too much bear, all right? Heartbeat it is, okay? So let's go ahead and step through this. So this service over here is fine. All it needs to do is just keep resolving the same thing. This service over here, however, let's say, actually we still haven't learned at which points do these things get recreated. I will register and add change token over here, and I'm going to need to create a new change token. We have a cancellation change token to which we can supply a cancellation token. So let's create a constructor where we're going to create a cancellation token source, a new cancellation token source. There it is. Create it like so. We're going to create a task which we're going to run, which is going to be effectively a trigger. All right. And I think you can do this somehow with a timer, which I'm not too interested of. But we're going to delay for 5 seconds. Okay, same as the other timer. And on the cancellation token source, we are going to cancel. Okay, so it's kind of like just a background task. Then with the cancellation token source, we are going to supply this over here. And we can probably kick off this task here because it gets triggered once. Okay. We're not going to wait on this. We'll just kick it off. But here we're going to pass the token. Okay. So what we're trying to understand here is will only this get reran, or will it try to actually recreate this endpoint provider? Okay. So let's go ahead and restart this. And also, I guess another thing to find out is our list of cancellation tokens going to be increasing? Yeah. So let's go ahead and run this. I'm going to try to stop saying let's go ahead. Okay. So there we go. We obviously don't have actual endpoints to call, but here is the recreation that is happening, right? So it's only populate async is being called. It's not actually triggering the factory of the provider again. It is using that provider to kind of maintain that list of endpoints, okay? If I take a look at the endpoints, it looks like we have only 2 change tokens. And if I keep refreshing this, we take a look at the endpoints again, we have 2. And again, looks like it's effectively not stacking these change tokens. It has the configuration reload and it has the, what's it called, the cancellation change token, okay? So now that we know that we are, I got all sorts of windows open there. But anyway, so the endpoint factory, let's go ahead and move that into its own file because we don't really need to do too much over there. Actually, I can move I probably spoken a little bit too soon. I'm gonna have to have a constructor over here and inject an service provider because this is a singleton, and I'm gonna need to resolve a what's it called? A scoped service, which is the database. Okay, so for this, I'm gonna go ahead and add this parameter to the other class, just like that. Here's my service provider. I'm gonna go ahead and create that, and as I'm canceling, over here in the database, I want to go ahead and look for the nodes that are not myself. So another service that I want to inject over here will be the server ID. Okay. So the server ID, let's also place it over here because I'm going to have to basically say, get me services which are not myself. I'm going to go ahead, add that parameter, and I think that will do. Format this and add a field. So the task, I'm just going to go ahead, move it to the bottom. The change token can stay over there. And then with the service provider, we're going to get required, not yet. We're going to create scope, right? So var scope get what's called service provider, get required service, I document session, and actually here I can do I query session because that's all that's needed over here. Okay, I'm querying. I'm not going to be saving stuff to the database. So query session. Let's go ahead and query our node entities. Okay, I want to query where if I have now, so date time offset UTC now, and I will subtract time span. Let's say, what do I want my cutoff to be? Let's say from seconds, 30. So everything that's alive time, right? So last updated is higher than alive time. Those are the nodes that I want. Okay, so var alive nodes, and I'm forgetting, and xid doesn't equal to server ID. Okay, make sure I get the ID property of the server ID. I can pass the cancellation token over here, and here are the live nodes. So live nodes for each live node that I have. Make sure that I await on this. For each live node that I have, I want to be able to register its URL, which we don't have on the node entity, right? So this is another thing that you actually want to store here. Okay, so the address, we can set it multiple ways. We can do it through app settings, but when I'm going to be publishing to the, to the bin and obj directories right over here, all right, this isn't exactly going to, well, allow me to configure app settings. I think the easier thing for me personally right now, since I'm not actually, in this microservices environment, I'm just gonna have to maybe use the web host, use URLs, and supply the address through args. Okay, this will specifically set the URL of the service. So with the server ID, potentially I want another configuration, server URL. This is going to be, or let's say address, right? Let's say address get set. This shouldn't be set like so. There we have it. Okay, so just another configuration class. I'm very, very confident that you will find a way to configure this in your own environment if you're ever looking for something like this, right? This is pretty niche stuff that I'm showing here. And we're going to set the address here as well. If we don't supply this, we're going to get an exception. So hopefully if we resolve the builder, we don't need this anymore. If I .NET run, it's just going to explode with the out of bounds exception. So anyway, we will have to go to the heartbeat. We're going to have to inject a server address. I'm pretty sure there is something, maybe you can do something with the features to get the address. I can't remember. I think that was old feature that you could actually get the address from Kestrel. I don't actually create a field. just doing a little bit of yapping. All right, so there we go. We set the ID and the address. Server ID there, yep, and that should be it. So for the live nodes on the endpoints, we want to go ahead and add a new endpoint, okay? And I'm pretty sure it's not that kind of an endpoint, it's a service endpoint. So new, I'm surprised that it is having a little bit of trouble. So service endpoint is abstract. I'm gonna go ahead and go to implementations. There is a service endpoint implementation which is sealed. So I'm not allowed to touch it, okay? So I'm gonna have to go ahead and implement my own service endpoint. Well, why, if you're exposing an interface, why would you, have some kind of tool to work with, my endpoint class, I guess. Let's go ahead and implement this. What am I gonna have to override over here? Endpoint and I feature collection. Let's go over here, a new my endpoint class. All right, that's happy with that. Features, I'm not sure why I need to supply features. I would say that's a weird thing to ask for. And then we want endpoint, but it's not allowing me a setter on the endpoint. Okay, so maybe I will just ask for that in the constructor and set the property there. Okay, we're gonna have a new URI endpoint, a new URI, and a live node address is what we're gonna, we should be able to supply it over there. Features, I don't really care too much about features. Let's see if it actually works this way. Okay, so there we have it. Let's go ahead and figure how to run this thing. So, or actually, how do we even want to test this, right? So the way that I had the service over here, so just to kind of call to RC test, let's put a test endpoint over here, and we're gonna put test over here, although this is just going to ask for, let's say, ID and server address, right? So address, and the things that it's going to return is a new object, which is ID and address. Okay, so in the end, when this will call out to this endpoint on these other services, it should return an object that we're just going to effectively dump out to the browser, and we're going to know which node this effectively came from. Okay, so let's go ahead and .NET build. This should hopefully goes without mention, build the project. And in here we will .NET app.dll, and I need a parameter, let's say localhost 5050. Let's see if this works. Maybe it wants HTTP, and there we have it. So let me go ahead and open this over here. It responded with a 500, so node not known. So that is fine. We're gonna select from entities over here, so we should have a node entity that is fairly recent, so 2110. I don't see it here. That's because we have multiple. And anyway, so that should be that. Don't mind the formatting on this very zoomed in terminal. It is absolutely horrid. So anyway, we have 5050 checking in with PostgreSQL, having a good time. Okay, so what do? We open another terminal, and we bring up the previous command, and we do 5555. Okay, that's running. Let's go ahead, come back here, refresh. Should get a what's it called, command here. Maybe it errored because it still hasn't found the node. Nope, still hasn't still hasn't figured it out. So something is going wrong. So I have these two two nodes running. I'm gonna go ahead and debug with the app, and hopefully it will actually be able to query the live nodes, and we're gonna see, is it adding them, is it not adding them? Well, yeah, what's going on? So let's go ahead, debug this. And there we have it. So live nodes, there are 2 of them. Let's go ahead and see if those are the 2 nodes. So 50/50 and the other one should be, the other one. So let's go to over here. We should have the endpoints, which, well, there should be 2 of my endpoints with a feature collection of null. So here are the 2 endpoints. Let's go ahead, play this out. And it looks like the one endpoint that I have picked is not supported. It's a classic, really a classic. Okay, I'm gonna stop these 2. We are gonna try to look for new endpoints. So on here, we're gonna have a new, and actually to figure out which endpoint I need, I'm probably just gonna go to endpoints, service endpoint, and again, take a look at the implementations, which is the service endpoint implementation, and see what kind of endpoint it is trying to use. So over here, I see that it is using, well, it is capable of 2-stringing a DNS endpoint. So maybe a DNS endpoint is what we want. So let's go ahead, get rid of all of those. Replace URI endpoint with DNS endpoint. And what do we need to give to the DNS endpoint? String and int. Perfect. So the address that I'm storing, Microsoft is having a good time at, having me here. So let's quickly collapse the bin, node entity. We're gonna change this to host and this to port. Let's go ahead and in the heartbeat, we will need to set the host and port. We're going to split by, let's say, colon, and grab the first here. We're gonna do very, as I would call, ape logic, just super simple. We're just gonna split, get the first and last. So when it comes to actually launching this, we're not gonna be supplying HTTPS, or we will, but let's, what's it called? Let's trim at the start the HTTP that we're supplying. Actually, that just wants a character. So maybe what I will do is, again, super simple, split, last, there we go. So the forward slashes that I was passing over here, yep, I should get about yay much. Okay. So with that, let's see where else do I have errors over here. So a live node, I'll have host and a live node. I should have the port, change this to integer, heartbeat, I will need a quick int parse, boom, okay, there we go. Let's go ahead and start this. So 50/50, we're gonna start. This one I will actually launch separately with a debugger, and let me just double check that I still have my breakpoints in place. Okay, so let me just put it over here. Well, this is going to refresh on its own. Value cannot be null. For some reason, the host parameter is null. So let me go to the database. I will truncate empty doc entry. Okay, and I will select everything from there. And the address looks good. One of them looks good. Which one was that? It's this is good. This is bad because we are running the old build. Okay. Lesson learned. We want to .NET build. Again, I will just quickly truncate the database. We're gonna start at 50/50 again. I'm just gonna double check that it's registering good entries. So 50/50 and 50/24. Okay. So now with the debugging build that I have going over here, if I refresh this, hopefully on the endpoints that we're adding, we're gonna have one. Okay, and that one endpoint should be 50/50. Okay, schema unspecified, but well, hopefully that's not a problem. Let's take a look at the exception. What's happening here? It looks like something is happening in the service discovery. at line 48 there. Okay. We're gonna go to line 48, and I have the iHost name feature on the features missing. And that's probably because I'm not setting this at all. Hello? You add the thing there. Okay. I gotta go to new line. Okay, hold it. Let's stop all of this, rebuild. Let's start this thing on this address again. Just gonna quickly truncate the table. Okay. We're gonna restart the debugger. Now hopefully this maybe works. Okay. So over here, okay, I'll have a new tab. Let me close all of these previous ones. Give this a good refresh. On the endpoints, we should have one. We do. I'm not gonna check the address. Come back over here, and there we go. It's the one and only, and it keeps refreshing. Okay. So the point here now is that if I start a new service at 55, over time that should register, and now we're getting this new address in there. And as I'm spinning up more and more, well, these services all start pulling to the same database. They are all aware of each other, or they can start, talking to each other. So you can start registering information such as how many tasks a thing is performing, or basically what's your load. 50%. I am at 90% load, you're at 50% load. Here, have some of these tasks which are, a little bit heavy, or I can't start a task because I'm full. Find me the node which is, a little bit less load, and give that to that node. Okay. Anyway, this problem can be similarly solved with a queue. Well, I'm busy. Place this thing again on the queue and stop pulling the queue. All right. But nevertheless, here is a little experiment on how you can get peer-to-peer communication set up using this new Microsoft's service discovery package that was introduced as part of .NET Aspire. All right. With that, hopefully, if my OBS will work, there we go. All right. With that, thank you very much for watching. Hopefully you've enjoyed the video. Don't forget to leave a like and subscribe if you did. If you have any questions, make sure to put it in the comment section. If you would like the source code for this video as well as my other videos, please come support me on Patreon. I will really appreciate it. And as always, a big and special thank you goes out to all of my current Patreon supporters. You help me make these videos. Again, thank you for watching. Have a good day.